Video number 7, made by Akula and translated by Wesley. The same day, November 1, we have actually 3 videos, and I'm trying to post them. Schematic was released about 1.5 weeks ago, and now Akula is doing the explanation. I have some notes of mine. Please do not confuse what I'm saying and that what he's explaining. And I'm going to try to make a very much clear distinction between what he's saying and what I'm saying. Let's start it. Hello guys. We're going to be following that schematic. On the left hand upper corner you see schematic of Akula. The device doesn't utilize any power supply at all. It needs a few seconds from battery and then it produces the electricity. It's a free energy base. You see 2 microchips in here, and actually it's a sort of PLL synchronization signal, which allows 2 signals to keep that synchronization within a certain range. He's gonna show how to test it properly. So those 2 chips is a sort of PLL. And over here you see the part of the schematic that is responsible for the signal transfer. That transformer that you see he's pointing, he's going to replace with a signal generator and connect to the 2 points, and that's the generator that he's gonna be using. And right now the generator is switched to the sinusoidal signal. And the signal is connected right before the plug with the 4 diodes. That what he's pointing actually is the point where you connect the generator, so then you have the influence of the collected right hand side from the signal. Those are the points. He's got 2 signals right now. That signal, the upper signal is connected ready to. Exactly that point. And as the right before the driver, so the transistor, I cannot read what transistor is that there. It's a part of the driver. And that microchip is the signal transfer. That's exactly the point where the first upper signal is being measured. And the second one is connected exactly to these 2 points. So it, instead of the transfer to the right hand side, we have a generator connected. He's trying to explain how the system of synchronization between those 2 signals is working. He has a sort of the automatic frequency adjustment. He's actually creating something that he calls corridor, which is the tunnel, but actually we're talking about a certain frequency range. So that would be like if you can imagine the filter, which you have a lower edge and the upper edge. And the 203.9 kilohertz at 8.5 volt is the signal that is being given from the signal generator right now. What he's gonna do is he's gonna try to detune the output before the driver, which is the upper one. And this one is tuned to 63.2 kilohertz. And the lower shape is regulated with the resistor R14 exactly where his finger is right now. That's the one, R14. If you need more range of regulation, then you minimize the resistance of the resistor. So again, this one is being used for the lower range of the regulation. So again, we're coming to the screen. We're giving 51.2, but we have a steady synchronization at 63 point. So again, 51.21. We're giving it to the input. And we have a synchronization at 64 kilohertz. So now he's trying to adjust the generator to exactly the frequency of synchronization, which would be 64 kilohertz. So what he's doing right now is he's progressively increasing the frequency, trying to see at which point he will break the synchronization of those two signals. Yeah, this is like a PLL circuitry. So what I believe what is going on here, that's my comment right now. Remember the Lithuania experiment. And I'm going to use this shape how the Lithuania experiment was working. We've been giving two signals to the ferrite cord from the Russian TV, Rubin. The secret of Lithuania experiment where we were getting 60 watts, 160 watts, 600 watts, and 1 kilowatt output from few milliwatts to generators was because from 0 point of the amplitude, from 0 point, and almost to the maximum, 3% before the maximum, we were stopping, we were giving the huge spikes, which were the square signals. And then when we went down from 0 down, we were doing exactly the same. The difference between me and Akula is that Akula trying to say the signal should begin from that point, right after the maximum, and goes up. And goes up to the next maximum before the maximum. But of course, that's difference of opinion. I'm not trying to correct him as he's the one who built the device. I am not. I'm working on Coleman, so I'm in different field. So now he's changing frequency to 72, and he's trying to see when the synchronization will be broken. He's increasing to 92 kilohertz. So you can look at the screen of the oscilloscope and see at which point it starts to move, the lower one. Now he's going to 116 kilohertz. Okay, he has 157 right now. 187. 216. But you see the synchronization was there broken. The lower signal is moving left and right. So the range of regulation at which the synchronization is kept is from 60 kilohertz to 180. Okay, from 60 kilohertz to 180 kilohertz. That's the range of regulation. So below and above, synchronization doesn't work. That's what he calls, that's how the autocorrection works. So the signal that you giving that sort of to that sort of corridor, the channel, that is the frequency that you're getting on the microchip. The increase of the voltage is being done on leg number 9. Now you see another resistor at the bottom of it, and that's the potentiometer. Is responsible for the upper part of the bandwidth of the frequency range of the corridor, which would be the channel. So again, we're dealing with the lower frequency and the upper frequency of the maximum and minimum. Try to not concentrate on that jumping mouse pointer, because I have had a problem with that video previously, and I'm just re-recording that, the voice that should be synchronized with the video. So we're going back to the Akula's explanation. So the upper part of the frequency range has to be regulated and minimized, and if you don't do that, you might have a very high attenuating signal. Yeah, you see in here 2 transistors. It's a switching circuitry. So you need to keep under control the upper part of the frequency range. To the point at which, you know, that generator is not jumping over the range of frequencies. So now leg number 14. Number 14 is connected to, I believe, number 9 at 748C14. And that's the input, and the output is exactly the point where he and finger is showing. Okay, so the first signal goes to 14 and the second one goes to the collector of the transistor. So now he's gonna be putting the probes from his oscilloscope from 2 channels. Okay, this is the part of the schematic that is responsible for keeping synchronization. Okay, fortunately we have a first channel already in the output. That is the point exactly pointed with his finger. I'm trying to come back to that. That's the point. I'm actually replaying the clip again. So that's the point. And the second channel is going to be put on the leg number 14 of our generator. So let's see what we have. He's changing the division per voltage right now between those two signals. And you see they are right now perfectly aligned. The time interval is exactly the same. I see difference in division because one signal is bigger than the other, but that doesn't matter. So in time, in phase. So they are pretty much synchronized. It's a pity that I don't see the frequency division. That's the division from here to here. The blue one is the input, the number 40 leg. number 14 in the looping system. And the yellow one is the output driver. That's the point. And here we have the resistor. That's the resistor. And he's going to be changing the resistance of the resistor. And actually he's going to be changing the time interval between the one and the second one. That's what he's doing right now. If you recall the doing experiment, it is sort of giving an impulse at the proper timing. The only what I don't like in here is that the frequency of both is quite of low. As in Lithuanian experiment, we have had one signal at 50 Hz and the other one was at 1.2 megahertz. We have also envisioned that one of the signal could be a sinusoidal signal. But this is my node, it's not his node, so don't take it for granted in terms of Akula device. From zero here, you actually have a voltage down and a voltage up, unless it's with the offset, but it doesn't sound like that. So again, it's sort of the PLL loop. You can also make it from two regular signal generators, and you could use the trigger port in it just to achieve the same. But if you don't have the money to buy expensive equipment, eventually break it, you could use few transistors and do it. Now he is trying to better show us and understand, better for us to understand the mechanism. You see the trigger, the set point is not holding. So now he moved a little bit the lower one, and you see the change in the timing. And why do we need that? Now he's gonna make a drawing, and there you go. You're gonna see something that would be sort of like the Lithuanian experiment. In reverse loop, we have a sort of this kind of shape, and then we have a point. There are 0 points. So 0 voltage points. Of course, they might be also maximum current volts, but we're not going into it right now. So whatever you have a 0 volt, you have a maximum current. As That's what is typical. So he is drawing right now the 0 point line. He is right now trying to find better light, complaining about his camera not working good after the first experiment they have made. Okay, we see this shape at the back looking, and he's drawing that shape. And of course he's trying to keep it in time dependency. He's pointing that we need to put it at the proper timing. Okay, the corner that he's drawing right now, he says, should be right after the maximum. So here's what he's saying again, which I have a absolutely 180 degrees opposite opinion. Okay, so we have a signal going from the left to right. That's how it goes in time. But he's saying that he needs to go from the maximum towards the minimum. As in Lithuania experiment, we were actually starting from 0 and going to the up of the amplitude. And then at the reverse part of that shape, we are having exactly the same action. Well, you gotta understand that we were delivering few milliwatts into the Lithuania experiment, and we were getting up to 1 kilowatt out. So the explanation of Akula is opposite. He says right after the maximum, you implementing the shape in here and going down to the 0. So so he's using the dying part of the amplitude. We're using the growing part of the amplitude. But the way that he drew it on the paper, it looks like that if you put the vertical lines, he is starting right after the maximum of the signal at the bottom and going up to the 0 up to almost the maximum. So we should also take into consideration that he might not trying to give us all of the information, and he wants really the time for whatever he's doing right now towards the patent protection. But anyhow, I'm pretty much thankful to him for his objects. So you see right now how he's doing that. So comparing to the Lithuania experiment, this frequency could be 100 times bigger than the first frequencies. So frequency of one shape in Lithuania experiment was 50 hertz, and the other one was 1.2, 1.8 megahertz. But the mechanism is very much similar. Maybe the key issue that was not explained in his face. It wouldn't hurt you to try both. If you do it the way that I explained, Lithuanian experiment is gonna work. But remember the precaution that we have had from the ferrite strong X-ray beta and gamma. It looks like we had that. That note especially for my safety of talking. I wish good to everybody. That was last words that he said. For those who do not know Lithuanian experiment, please Google Lithuanian experiment. Also Google Arunas or Stivep1, STIVEP1, Wesley, which is me. Thank you, Akula, for giving us all of that complicated sort of circuitry. I believe strongly that it could be done much simpler way. So within a matter of few minutes, two generators could simply simulate exactly the same. And that's what I found on next video that I didn't translate yet. Somebody was messing up with my editing program. So again, it's much cheaper and safer to build generating circuitries on few transistors or chips instead of risking expensive equipment. So I wish Aqua would explain us the rest of it. So Roman, be safe. Thank you very much. Спасибо большое, Roman. And this is Wesley, channel STIVP1, STIVEP1 on YouTube. Have a good one. And thank you for your attention.